The Gigabyte Aero 15X9 is a thin and powerful laptop with some serious specs inside, but high-end hardware in a smaller form factor generally leads to heat and throttling. So let's take a look at the thermals and see how we can improve performance using the new AI feature, Undervolting and Overclocking. In my configuration here, I've got the Intel i7-8750H CPU, but the X9 is also available with the i9-8950HK. Otherwise, the other major heat generating component is the 2070 Max-Q graphics, and the higher tier Aero 15Y9 is available with the 2080 Max-Q. I'll also be comparing the X9 with the 15X with 1070 Max-Q in a future video, so get subscribed for that. Thermal testing was completed with an ambient room temperature of 24 degrees Celsius, so expect different temperatures in different environments. Also keep in mind there are heat pipes shared between processor and graphics, so a change in one component may affect the other. I'll also briefly talk about Gigabyte's new AI feature that comes with the V9 Aero laptops, so the new ones with RTX graphics. There are two modes, AI Edge and AI Cloud. AI Edge processes the data locally to make the best decisions in terms of what to change, like fan speeds and power limits, while the AI Cloud setting will send data to Microsoft and get the best settings for the workload based on other user-submitted data, so I'm expecting it to perform better. Otherwise, all other tests had AI disabled unless stated otherwise. Starting down the bottom of the graph, at idle the temperatures were on the warmer side as the fans were basically silent. The gaming results were tested playing Watch Dogs 2, as I find it to use a good combination of both processor and graphics. The stress tests were done by running the Heaven benchmark and the AIDA64 stress test at the same time as a worst case scenario. The CPU was undervolted by -0.12 volts, as denoted by a UV on the graph, and the graphics overclock was with a 90 MHz boost to the GPU core. In every single other test, the CPU was thermal throttling at 90 degrees Celsius, as shown by the blue bars, while the 2070 Max-Q graphics was thermal throttling in most tests, anytime the green bar was at 86 degrees Celsius. The graphics only stopped thermal throttling when the fan speed was manually maxed out, and at the top with the Thermaltake Massive 20 cooling pad in use, I got the best results. These are the average clock speeds for the same tests just shown. Let's start towards the bottom with the gaming tests. Despite thermal throttling taking place for each of these tests, there are clock speed differences from the different settings. Both of the AI settings were giving better performance compared to just running the laptop at stock. However, from what I could tell, the AI Cloud setting ran with a higher fan speed, which reduced thermal throttling, which is why I think it was ahead of the AI Edge results. Either way, with my manual -0.12 volt undervolt to the CPU, plus 90 MHz overclock to the graphics, and with the fans manually set to maximum, I'm getting a big improvement over both stock and the AI settings. With the stress tests, it's worth noting that with the fan on stock but graphics overclocked, I saw the worst GPU performance so far. It was already thermal throttling, so this basically makes it worse until we boost the fan speed. At the top of our graph, with our best case result using the cooling pad, the 8750H was 500 MHz from being able to reach the full 3.9 GHz turbo speed due to thermal throttling. Despite the thermal throttling, it's worth keeping in mind the gaming performance tested previously was still fairly decent. These are the clock speeds I got while just running CPU-only stress tests without any GPU load. And we're seeing higher clock speeds now as there's less heat in the system without the graphics contributing. At stock, I was hitting power limit throttling for the first time rather than thermal throttling. By boosting the power limit with Intel XTU, the clock speed was improved. However, this now resulted in thermal throttling, which is why the undervolt at the top of the graph allows us to hit the full 3.9 GHz turbo boost speed of the 8750H. These are the temperatures for the same tests just shown, and we can see that with the power limit boosted, the 90 degrees Celsius throttling was reached, while the undervolt improved temperatures by 7 degrees Celsius while also boosting clock speed. While it was possible to boost the power limit of the CPU, this was not attempted in the gaming and stress tests shown previously. There's no point, as thermal throttling was taking place without it. We only need to look at boosting the power limit if we're hitting power limit throttling, but that wasn't the case there. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks. While it was possible to get full CPU performance in AIDA64 with the undervolt only, in Cinebench I still had power limit throttling with the default 52W TDP, so I had to boost it a bit to almost hit 1200, just a little under what I'd normally expect from an unconstrained 8750H. Here are the GPU-only clock speeds while under a graphical-only stress test, at stock and with a 90 MHz overclock applied. These are the temperatures from the same tests. No change with or without the overclock. and not reaching thermal throttling at 86 degrees Celsius, as we saw in the combined CPU and GPU loads earlier. So how do these performance boosts actually translate into games? I've tested with the exact same Windows, Nvidia, and game updates installed. Far Cry 5 was tested using the built-in benchmark at 1080p with ultra settings. Down the bottom, I've got the results purely from running the laptop at stock. Just above this is with the fan set to full speed, which gives us the second best performance. The AI Edge and AI Cloud settings are giving better performance compared to stock with the default fan, but simply setting the fan to full speed was enough to provide better performance as it helps reduce the thermal throttling. Finally at the top, once the CPU is undervolted by minus 0.12 volts and the graphics overclocked by 90 MHz on the core and 400 MHz on the memory with the fans at full, we're getting the best performance. Not surprising, I think manually tuned settings will always win. As for the external temperatures where you'll actually be putting your hands, at idle it was in the low to mid 30s, warmer up the back and cooler over the WASD keys. While gaming, the palm rest and touchpad was still fairly cool. The middle of the keyboard was fairly warm though, getting to 50 degrees. The WASD keys are still sitting at around 30 though. Similar deal with the stress tests running. The back gets to the high 50s as hot air is exhausted below the screen, but I don't think it's an issue as you don't rest your hands there. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle, it was almost silent, and then while gaming and under stress test with the fans at default, it was actually very quiet. Much quieter than most other similarly spec'd laptops I've tested. With the fans maxed out, it was quite a bit louder. Now about the same as many other laptops I've tested. And as we saw earlier, the fan boost improves CPU and GPU clock speeds by a fair bit. Overall, my Aero 15X9 is a hot machine. Although at stock, the fans aren't actually that loud. And as we've seen, performance is negatively affected as a result. And this is with the i7-8750H and 2070 Max-Q. The Y9 is available with the i9-8950HK and 2080 Max-Q, so I'd be interested in seeing how that goes in the same body. I didn't personally see much of an improvement with the AI feature either. As we saw before, I was able to get much better results with my own simple tweaks, though of course most people probably won't be doing that. Compared to running at stock with AI disabled, I was seeing some improvements with the AI, but better results were had by simply maxing out the fan, which is something anyone can easily do. I think in future, as different workloads are learned, it may improve over time. It could just be that the AI isn't currently optimized to best handle the workloads that I was testing. Especially the AI Edge setting, as I presume that learns from my behavior, whereas AI Cloud has more data to work with. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements. So don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit, I'm not able to try that. If I change the paste, the next reviewer will unknowingly report incorrect thermal results due to what I've done. I have swapped the thermal paste on my personal Aero 15X, although I didn't personally see a difference there. And many people who have gone to liquid metal have also noted minimal changes. So it may just be the case that the cooler isn't sufficient to dissipate the heat, regardless of the contact material between the chips and heat pipes. In any case, undervolting and raising the fan speed is much easier for anyone to do, and as we've seen, it did improve performance in this laptop. Let me know how much of a performance boost you found by undervolting your hardware, and what you thought of the improvements here. And don't forget to subscribe for the full review of the Gigabyte Aero 15X9 laptop, as well as future tech videos like this one.